In this video, we're going to take a look at the importance of identifying the base when evaluating expressions with exponents. So the key thing to remember is that an exponent attaches only to what's directly below it. So here in this expression, negative 7 squared, the 2 is only attached to the 7, not even to the negative symbol. So our order of operations tells us, PEMDAS tells us to do exponents before multiplication. So before this 7 can get multiplied by the negative symbol, we're going to do 7 squared, which is 49, and then the negative will attach. So our answer is negative 49. We're going to skip to example C and look at how that's different. Here, because there's parentheses, the negative is captured as part of the base. So here the base is negative 7. And a negative times a negative is a positive. So for example C, our answer is going to be positive 49. Going back up to B, negative 5 cubed. So the 3 is only attached to the 5. So we're going to do 5 times 5 times 5, which is 125, and then the negative attaches. Letter D, negative 1 to the 57th power. So here, because there's parentheses, the negative is captured as part of the base. So we're multiplying negative 1 by itself 57 times. And because 57 is odd, we're going to have an extra negative 1 at the end to flip it back to negative 1, right? The first 56 negative 1s will make 28 pairs. Each of those pairs will multiply to positive 1 because negative 1 times negative 1 is positive 1. But then that 57 negative 1 is going to flip it back to negative 1. Letter E. So one pattern you'll start noticing is if there's a negative symbol and there's no parentheses, it's going to be negative. Because at the end, the negative is going to reattach and make whatever you got negative. So 2 to the 6th power is 64. Then the negative attaches. Your answer is negative 64. Doesn't matter whether this is even, odd. If there's not parentheses, the negative is not captured in the base and is going to attach at the end. So F, 3 squared is 9, negative 9. Letter G. Here we have a negative 2, which is part of the base, and then this negative outside. So here we're going to have to go step by step. First, we're going to do negative 2 to the 4th power, and 4 is even. So we're going to get a positive. Negative 2 times negative 2 is 4. And then another negative 2 times negative 2 is positive 4. 4 times 4 is 16. So positive 16. Then this outside exponent is going to sneak in and flip it back to a negative 16. Letter H is trying to trick you because 482 is even, and if there were parentheses, it'd be a positive 1, but there's not. So we're just going to do 1 times itself 482 times, that's 1. Then the negative attaches, and our answer is negative 1. Letter I is different because the parentheses capture the base, and we have an even exponent. So we're going to have 241 pairs of negative 1 times negative 1. Each of those pairs is positive 1, so our final answer is positive 1. And finally, letter J, negative 5 to the 4th power. Our base is negative 5, right? So if we wrote this out, it would be negative 5 times negative 5 times negative 5 times negative 5. And each of those pairs is going to equal 25. So 25 times 25. And that is 625. So when you're evaluating expressions with an exponent, pay close attention to whether or not there's parentheses, because that's going to determine what the base is, what you're multiplying by itself.